This short clip is designed to take you through the application of the idea of complete combustion of alcohols and how to write the equation taking into account the fact that they already have an oxygen atom present in the OH group. So I've also added something to the definition of combustion, because there's a slight difference between combustion and oxidation. So let's start by looking at the simplest alcohol, which is methanol. So the first step is to look at how many carbons you've got present in your methanol and convert them into carbon dioxide. So if we take methanol, we know it's going to react with oxygen from the air because we're looking at combustion. We have one carbon present, and we know that the hydrogens are going to make water. So looking at methanol, we have 4 hydrogens, so therefore we need to double the water. So now what we've got to do is look at how many oxygens we've got on the right hand side and then think how many oxygens were needed to create all of those products. So looking at this closely, on the right hand side we have 4 oxygen atoms, and on the left hand side we have 3 oxygen atoms. Now we can't change the formula of methanol to suit this, so what we're going to have to do is look at how many times we need to multiply O2. So to make it 4 oxygen atoms, to balance the 4 oxygen atoms present in the carbon dioxide and the water, we've got to do 1.5 times O2. Now this is actually fine to do in organic chemistry, because quite often you're dealing with 1 mole of alcohol. Let's say if you're burning something and you want to work out the enthalpy of combustion, for example, you need to deal with 1 mole. So fractions can be used to allow you to work with 1 mole. So now we can change the number of oxygen atoms present on the left hand side to 4. Meaning the equation is balanced. So, what do we need to use the fraction idea for? Now, what we could do, of course, is double everything up to get rid of the fraction. So, for example, if you wanted to get rid of the 1.5, you could do 2 lots of methanol and 3 O2s, giving you 2 CO2s and 4 H2Os. But the problem with that would be that you'd be dealing with burning 2 moles of methanol and not 1 mole of methanol. So fractions of oxygen molecules are used to allow us to work with 1 mole of substance, which is an important consideration when we're looking at enthalpy of combustion.